Statistics. This is our last section of the semester. We're looking at what's called analysis of variance, which is abbreviated ANOVA. So this is an ANOVA test. What's good about this last section is that we don't really do much ourselves. We look at the data and we interpret the data. So a one-way analysis of variance, there is a two-way analysis of variance, but we are not going to get into that. We test the equality of three or more population means. Now it's strange because we're testing means, but it's called an analysis of variance. What we do is we analyze the variances basically within groups and compare that to the variance all together among the groups. So what do I mean? Basically, we're going to have three or more different groups. Let's say, for example, we were measuring the miles per gallon for different types of cars. Let's say we were looking at like coupes, little small cars, little two-seaters, maybe. They don't have to be two-seaters, at least two doors. Sedans, and SUVs, for example. So I have three, or there could be more. I could have trucks and all that stuff in there as well. Basically, we let the computer, we let StatCrunch, or whatever our program is, analyze the variances within the groups. We'll have data for each group, MPGs, a whole bunch of MPG data, a whole bunch of MPG data. We'll calculate the variance within the groups and the variance among the groups and see if there's a difference. And again, by saying we, I mean StatCrunch will do this. This is, again, a one-way analysis. There will only be one factor that distinguishes them. So again, this is miles per gallon, and our factor that's distinguishing them is what type of car we're looking at. So our factor is, basically small cars, mid-sized cars, big old SUVs. So basically what we're going to be doing in these is trying to figure out, are the means for each group, so like the means of coupes, the means of sedans, they'll say SE for sedans, and the means for SUVs, are they all equal? So basically, is the mean miles per gallon the same between these? Or is at least one different? So again, we're testing the means of three or more different groups. That is our null hypothesis, that they are equal. We're basically going to use StatCrunch, and I'll show you just a sec how to do that. We'll look for the p-value, and then we'll do our, if the p is low, the null must go. Same stuff we've been doing. If p is below alpha, reject. If p is bigger than alpha, fail to reject. And again, the null is equal means, that they are the same. So on our example, this is actually a table that we looked at way back at the beginning of the semester. We have IQ scores for different groups of children in the low blood level, blood lead level, medium blood lead level, and high. So basically what we're testing is, does the amount of lead in someone's blood affect their IQ? So one thing that's important with the ANOVA test, again, the null is that they're all the same, but the alternative is not that they are all different, it's just that at least one is different. So it could be that the low average does equal the medium average, but as long as one of them is not the same, maybe those don't equal the high average. So it's not that they all have to be different, just one has to be different. I've got all the data here already on a StatCrunch file. The directions for this are at the end of the PowerPoint, but it's very quick. We just go to Stat. There's ANOVA. We're only going to be doing one-way ANOVA. All we have to do is select the columns where the data is. So I already have the low lead, medium lead, high lead. Remember, I had to hold down Control to do that. I don't do anything else. Just hit compute. I am given a whole bunch of data here. So I'm given a whole bunch of data. This down here, the bottom half, is my ANOVA table. So again, on here, what we're looking at. So I've got my ANOVA table. A few notes here. SS stands for the sum of squares of differences from the mean. That is what variance is, where we figured out how far we were from the mean and we squared all those and add them up. The mean square is dividing the SS by the degrees of freedom. So on this problem, let me bring it up in the bigger version again. My degrees of freedom for the columns, there were 3 columns, so the degrees of freedom was 2. It did all this calculation of the sum of squares. It divided the 2022 by 2. That's where this number came from. The error is actually all the data, degrees of freedom of all the data, sum of squares of all the data, and then they divided the 29,000 number by 118 and got this, 248. This introduces a new test statistic. Don't worry so much about it, but it's called the F statistic. This is a different curve, but it looks a lot like chi-square. That number, F stat, was found by dividing the 1011 by 248. You divide those, you get this. Now, again, that is a, let me get rid of some stuff here. That is a new curve, but it looks just like the chi-square. So just as a review, we had the Z curve, the normal curve. We had the T curve, which looked a lot like it, a lot like Z. Then we had chi-square, which was skewed right. Now we have F, which is also skewed right. But again, don't worry so much about it. There still is a p-value that we find, and that's the most important part of this. So basically it's saying on this F curve, oh, that's terrible. Let's try that again. That's a little better. On this F curve, the F test statistic was 4.07, et cetera. The area beyond that is the p-value, 0.0195. So it's still an area in a tail, just like we've been doing for the past 7-8 weeks. So most important part is that we look at the p-value, and my alpha for this problem was 0.05. P is low, so the null must go. So we're rejecting equal means. So we're saying this 3 samples come from populations with different means. Now, it does not say which, the test itself doesn't say which ones are different, but you can look at the data. And actually this same data in a slightly different format is presented in the analysis of variance. Our low lead level, their IQs were around 102, 103. Once I introduced lead medium, and high groups were both about the same, but they differed from the low. So again, at least one of the means is different. So we can conclude from this, statistically, that having lead in your system, either of medium or high levels, will lower your IQ. We have statistical evidence of that. And on the last page is just a quick summary of how to do this in StatCrunch. Again, what's great about this last section is that everything is done by StatCrunch. We just basically have to look at the p-value and go from there. That does it for our last unit, our last section.